Hey, cosmic travelers! Welcome back to Singularity. I'm so stoked you're here today because we're blasting off on an awesome adventure with the ISV Venture Star, that epic ship from Avatar movie sailing 4.6 light-years to Pandora. This ship's got a Matter-antimatter engine to hit 70% the speed of light, plus some slick laser sail tricks to zoom through space. We're talking antimatter, wild costs, and a journey that's pure sci-fi gold with a dash of real science. So let's jump right in and explore this beast together. First up, what's fueling this interstellar road trip? The Venture Star runs on a Matter-antimatter engine, and that's where the fun begins. So, what's antimatter? Picture everything around you. Your snacks, your phone, the air, it's all matter, built from tiny particles like electrons, protons, and neutrons. Antimatter's like matter's quirky opposite. It's got particles that are super similar but flipped in key ways, like their charge. When matter and antimatter collide, boom! They zap into pure energy. 100% of their mass turns into power. That's why it's the dream fuel for a ship like the Venture Star. Let's zoom in on those particles. The antimatter version of an electron? That's a positron. Positive charge instead of negative, same mass, just a total vibe switch. For a proton, which is positive, you've got an antiproton. Negative charge, same mass. And neutrons? They're neutral, but their antimatter twin is the antineutron. Still no charge, but its insides, like quarks, are flipped and it spins the other way. Every particle's got its antimatter match, and they're the stars of this energy-packed show. I will talk about antimatter in depth in the next video. Making antimatter, though? Not so simple. Positrons are the easiest to cook up. Scientists use stuff like radioactive decay or particle accelerators to make them. But antiprotons and antineutrons? Way tougher. You need giant machines smashing particles at crazy speeds. Think CERN-level tech. Price tag? 1 milligram of positrons costs about $30 million. Antiprotons and antineutrons? They're ballparked at 100 times that. Billions for a tiny bit. Positrons are the budget pick, which is probably why the Venture Star leans on them. Storing positrons is another puzzle. You can't just toss them in a bag. They'll hit regular matter and explode. Enter the penning trap. A fancy magnetic bottle using electric and magnetic fields to keep positrons floating in a vacuum, safe from touching anything. It's like a sci-fi containment field. Works for small amounts, but storing tons for a spaceship? That's a challenge we're still dreaming up solutions for. Super important for the Venture Star's mission. How does the ship get its positrons? In Avatar, they've got a fusion reactor on board. Sometimes it spits out positrons too. So the reactor powers the ship and churns out positrons, which mix with regular matter in the antimatter engine for that explosive boost. How much positron fuel does it need for Pandora? 4.6 light-years away. Estimates say 200 kilograms to 2,000 kilograms, depending on the ship's size and thrust. Let's go with 1,000 kilograms for a nice middle ground. How much would that cost today? If 1 milligram is $30 million, a 1,000 kilograms is $30 trillion. Yep, 30 trillion bucks for the positrons alone. It is 1 year of the USA's GDP. For the Venture Star, human resources, and other expenses, this voyage to Pandora will cost $60 trillion. Now let's talk specifically about the journey of the Venture Star. First, let's briefly look at the structure of the Venture Star. On one end, there is a laser shield, and on the other end, there are massive radiators. Two large radiators dissipate the heat generated by the antimatter engine. In the center of the radiators, there is a shaft connected to a 16-kilometer diameter laser sail. Behind the radiators, the antimatter engine is installed, which pulls the entire spacecraft forward from the front. 3 layers of laser shields protect the spacecraft, while it is gaining thrust from an ultra-powerful laser beam fired from the moon, which hits the laser sail. Behind the shields is the crew area and cargo storage. The laser sail, with a diameter of 10 miles, unfurls from this pointed structure. This ultra-thin sail can automatically fold and unfold. Its design is similar to Count Dooku's starship in Star Wars. When departing from Earth, the Venture Star is first accelerated by the combination of the laser and the antimatter engine, eventually reaching 0.7 c, 70% the speed of light. Once acceleration is complete, the spacecraft rotates 180 degrees so that the laser shield faces forward. During interstellar travel, this laser shield protects the ship from space dust. When the Venture Star arrives at Pandora, the antimatter engine activates again to decelerate the spacecraft. It takes about 6.57 years to reach Pandora from Earth's perspective. 4.6 light-years at 0.7 c. Relativity shrinks that to 4.8 years for the crew. On the return journey from Pandora, the spacecraft first accelerates again, using the antimatter engine to reach 70% the speed of light. It then performs another 180-degree rotation so that the laser shield once again faces forward. As the spacecraft approaches Earth, it redeploys the laser sail and uses the combined power of the ultra-powerful laser and the antimatter engine to decelerate. What do you think, Singularity Squad? How would you tweak this ship? Got any ideas for our next topic? Drop them in the comments. Maybe we'll explore Dyson spheres, time travel, or alien tech next. I'm all ears. Alright, that's our interstellar ride for today. If you enjoyed this dive into the Venture Star, smash that like button. It helps us tons. Not subscribed yet? Join the Singularity fam. Hit that button so you don't miss our next cosmic journey. Until then, keep dreaming big, keep staring at the stars, and I'll catch you in the next one. See ya!